through 12. And if I was really thinking, I would have went through yesterday and fixed my answer key so it's precise, but it's not, so I'm going to have to rely on some of you guys to tell me the answers again. So for number 7, I got somewhere between 5 and 6 hours, but you should probably have a more precise answer. What did you get, Zach? Yeah, I'm trying to decide how I got 5. Let's just go over 7 together, because I'm not sure how I got 5 to 6 there. We'll look at 7 together. 8, you should get $1,568.52. For 9, you should get 20 to 21 years. What exactly did you get there, Zach? 20.519 sounds more precise and probably right. For 10, I got somewhere between 4 and 5 hours. Zach, what did you get there? 4.074. Sounds good. For number 11, I have about 480 days. All right, and for number 12, in 2020, population will be 7.66 billion, and in 2050, it will be 10.73 billion. And this reminds me, we need to watch this video. The one, I meant to watch it yesterday and I forgot. This is a crazy video. You may have seen it in some other classes before. But if you haven't, you need to see it. So, we're going to watch it and then we'll talk about these questions. So the notes that we did while we were at home on Monday. I said there was a video, but I didn't want to show it because I wasn't sure if it would work well through the Google Meet, and we would just watch it here, so we're going to watch that now. Let me get that link. I can't remember. Okay, here we go. All right.
An environment is a system of living things.
Is it going to work? Okay, I think it's going to work, but I want to do the volume. Let's see, let me change this so that it goes to the projector.
The capacity of our environment to provide space, to produce food, is to supply energy for all living. Humans thrive on less than 17% of the Earth's surface, and only about 4% can grow crops. We depend on these limited resources for our survival, yet we are increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 CE to the present, and project our growth into the year 2050. Population concentrations will be indicated by dots, each of which will represent 1 million people. In areas where people are spread out and don't live in concentrations of 1 million, dots are placed in the middle of their approximate range. Historical references will be provided by images and text at the bottom of the screen.
I think that video is pretty crazy and a little scary, because there for a while you can see exactly what's happening, right? Like the Black Death came up and you saw the lights go out in Europe. You can see whenever settlers start coming to America, you can see more lights starting to light up then. You had a few before, that was the native populations that were growing, but not as quickly as whenever not as quickly as whenever Europeans moved to the Americas. But then the last 100 years, you can't even tell what's happening. It's just crazy everywhere, right? So that is what exponential growth looks like. For a very long time of human history, the population was growing. There were a couple places where it went back down. You could see at the Black Death it went back down. But for the most part, it was growing pretty consistently there. But within the last few hundred years, it has really started to shoot up, right? Because if you think about patterns with population growth, think back to your probably great-grandparents or great-great-grandparents, if you know anything about them. How many brothers and sisters did they have? My grandpa was one of 11. My husband's grandpa, he was one of 10. My husband's grandma, she was in a small family. There were only 5 kids in it, right? So think about what happens if every family has five kids, right? If they have 5 kids and those kids all have 5 kids and those kids all have 5 kids, you see population really starts to take off. At first it seems like it's not that fast, but it really takes off. So here's a question for you. How many children should, we're going to consider the unrealistic and not true consideration that you have every couple is always together and never splits up and goes to another direction, right? So because mathematically it's too complicated if we consider that. Let's imagine that every couple, so every person finds another person and they stay together forever and never split up and have children with other people. Just these two together forever. If we had that situation, how many children would they need to have for our population to stay the same? Nope. Because if you don't have any kids, our population is going to plummet. Because you're going to die. And so is everybody else in the world eventually. Okay? 2. Because they replace themselves. So if you have a couple and they have 2 children, they are replacing themselves. Right? So like if my husband and I we do have 2 kids. So one of them replaces me when I die. One of them replaces him when he dies. And the population stays the same. So if every couple, first of all, they have to be, together forever and only have, never split off. But if every couple has 2 children, then population stays exactly as it is. If we have fewer than 2 children per couple, then our population is going to decline. So it's going to start to go down. This is happening in a lot of countries in Europe. So lots of countries in Europe are seeing their populations decline. Like Italy's population is on the decline. Because most couples, some couples might have 2 kids, but there's a lot that have 1 or 0, in which case your population starts to decline. If you have more than 2 children, then your population starts to increase. And it's going to increase at an exponential rate based on the average for however many children that you have. So in the U.S., we are still seeing population growth, but not nearly at the rates that we were whenever, like, my grandparents and your probably great-grandparents were having kids. Because whenever all the farmers were having 12 kids to work the farm, population growth was really rising quickly. China, you've probably heard, China had a huge, like, their population was growing really rapidly. So I'm sure you guys have heard about what China did, what they do. You can only have one child, and it created a problem because a lot of families wanted a boy. So there were a lot of Chinese girls that got put up for adoption because the family wanted a boy instead of a girl. But China had a one-child policy, which it actually meant that, like, you could have more than one child, but if you did, you were going to have to pay, like, all of these, like, excessive taxes and stuff. So most families only had one child in China for a very long time. China now is seeing that they have lots of old people and not very many young people because every family could only have one child for a very long time. It did control their population, but right now they have lots of old people and they don't have enough working people to take care of them because their older people are starting to get older and sicker and not able to work, so there's not as many people to work because there's not as many people in the younger generation. So China has actually, they changed it several years ago to where you can have 2 children, and now they have upped it to 3 children, but it's not changing the trend because I guess people have decided that they prefer only having few children. So it kind of changed the culture, and so changing that rule is not fixing their problem back. So that's kind of an interesting thing to think about. India at one time had, like, population going, like, through the roof, out of control. It is even slowing down from where it was. But these are all really interesting things to talk about because whenever we talk about the environment, you hear a lot of people talking about electric cars and, reusable shopping bags and all kinds of stuff like that. And they are certainly we should look into any technology that we could think of to, help us with that because we don't want to all live in a place that is not healthy because we have ruined it. But the one thing I don't feel like you hear as much is population growth. Because the fact is that 1 billion people do not use nearly as much stuff as 10 billion people, right? So, we could all probably reduce what we use, but if we have 20 billion people on the earth, even if we're not using much, it's going to use up a lot more of our resources. So I think this is really interesting. I think probably the reason we don't hear a lot about population growth is because regulating population growth like they've done in China is what most people would consider an infringement on their freedoms in a very significant way, right? You do not want the government telling you how many children that you can have, and then certainly what happens if you have children that you aren't planning on having. You don't want to just, adopt them off somewhere, although that did happen some. Now, that did not mean like all Chinese people were doing that, but it did happen some in China where lots of girls were up for adoption because families wanted boys. But it just seems such an awful thing. So that's all kind of like interesting things to think about, I think, because that is certainly a major consideration when you're talking about the environment, right? Because if you have tons of people, they use up more resources. So kind of interesting. And it fits here because it's definitely showing that exponential growth. I think that we're already starting to see that slow down a little bit. It's not growing at the same rate that it was. And we may continue to see that to where it's not as much of an issue, but I don't know. Something interesting to think about, though, and something I feel like sometimes we don't hear as much. So let's look at the worksheet that you guys had. I wanted to bring that up, just sort of a little extra thing. So for the homework, Which one's, we need to look at number 7, because I don't even know if my answer's right on number 7. We need to really look at that. All right, so 2 friends start a rumor about Tristan. After 3 hours, the freshman class of 98 people have heard the rumor. If the rumor is spreading exponentially and continues to spread at the same rate, about how long will it be until the whole town of Elkin, which is about 4,000 people, has heard the rumor? Okay, so this one is a little bit of a tricky problem. And it's one step past what I'm going to ask you on the quiz. On the quiz, I would probably ask you how or what is the growth rate of this happening. So we've got 2 friends, and so we got 2 friends, and they are going to start a rumor about Tristan, and we don't know how fast this is going to grow. So I'm going to put B to the X power. X is where my time goes. For my time, guys, you are all looking at your computers and not at me. And I feel like nobody can tell me how to do this problem. So make sure you get off of that. All right, so time goes for your exponent. What number should we use for our exponent there? 3 hours, right? And we know after 3 hours, 98 people, the whole freshman class, know what's going on about Tristan here. So I'm going to put 98 over here. So this is one, it doesn't ask us to find the growth rate, but the growth rate's what's missing, so we got to find it first. So, Julian, what would I do to solve that equation? Trying to get that B by itself. What do we got to do first, Jada? Very good. We'll divide off that 2. That'll get rid of this for us. So we'll have 49 equals B to the 3rd power. So then, we'll see. Hank, I've got to get rid of that 3rd power. How do I get rid of that 3rd power? Okay? Who can help him out? When I've got something raised to the 3rd power, Ayla, what have I got to do? Very good. We're going to raise it to the 1 over 3 power. And so when we do that, we'll pull up the calculator over here. We're doing 49 to the 1/3 power. And so we will get 3.659 is our B. All right. Well, let's keep 3 at 5. Keep a few more numbers. Okay. So the question didn't ask us for the growth rate, but on the quiz, what I'm going to ask you for is the growth rate. So if it asks you for the growth rate, you're exactly right. We're going to subtract by 1. So I have 2.659305. And then what will we have to do with our decimal? 2 places to the right. So we would get 265.9. I'm going to just keep 1 decimal place there, percent. So whatever number you're raising this to the power, you're going to raise it to the 1 over that number power. So the reason that we do that is because 3 times 1 over 3 would just give us a big over 1. We get 3 over 3, which just equals 1. So it would get rid of your exponents on this right-hand side. You just have B to the 1st power. So if it was a 7, we'd raise it to the 1 over 7 power. Or if it was a 15, we'd raise it to the 1 over 15 power. Does that make sense? Yeah. Okay? Now, on the quiz, growth rate's what I would be asking you for. But this question wants to know how long until 4,000 people have heard. So to answer that, I need to put this back into the equation. 2 times 3.659305 to the x power. So if I go over here to Desmos, I'm going to type in that equation. To the x power. And in the other line, I want to know when the whole town of Elkin, 4,000 people, has heard. Okay? So I type in the second line, 4,000. I can't see it. What have I got to change? That y maximum, 4,000. All right, so right here, I can see I get 5.859. So 5.859 hours. It says that 2 friends started the rumor. So the initial rate is 2. There. Yes. Okay. All right, are we all good here? Okay, what's your question on number 9, Jada?
Would you just do 300 times 6.5, and then the x, which is just 3 of x.
All right, so on that one, on number 9, we're going to do 300 times, the account gets 5.5% interest, so that's going to be 1.055 here. And so we'll just put an X for our exponent because we don't know how long. And you'll use Desmos on this. So any how long problem, you're going to use Desmos. So 300 times 1.055 to the x power. And then the question wants to know how long it takes for it to triple. So if I start with 300, how much will you have once it triples? 900. 900. 300 times 3. Triple. Yeah, triple would be 3. So 900. And so you'll just figure out where those cross, and you're going to get 20.519 for that. Yeah, if it's a question that's asking how long, right, then the x is just going to stay in x, and you're going to type it into Desmos, and then you can use the graph to figure out when it reaches that point. Okay, yes, Presley. On 10 and 11? Okay. All right, so for 10, we've got bacteria. We begin with 5. So we'll have 5. And after 2 hours, the bacteria has grown to 2,000. I need to go back and change this worksheet to match the quiz a little bit better. This one is one where we're going to have to find the growth rate first also. So it's like number 7. So on the quiz, it would say what's the growth rate. But then you can use it to find the second part. So we don't know what the growth rate is here, so we're just going to have to use a B. And we know after 2 hours, so our time is our exponent, so we're going to put 2 there for our time. And we know that the bacteria has grown to 2,000. So we'll say 2,000 equals 5B squared. And so, Presley, what would I do to solve that for the B? Very good. So that is going to give me 500. Yes. And then, how do I get rid of that exponent of a 2? Very good. Raise it to the 1/2 power, which is actually like taking a square root. So you end up getting 20 for your B. You're doing 400 raised to the 1/2 power. So 400 to the 1/2 power. I knew that one in my head because it's a square root, and I know more than you do about fractional exponents right now. But you would just type it in 400 raised to the 1/2 power. And so on the quiz, I'd probably ask you for the percent growth. So if it asked for percent growth, you would subtract 1, so it'd give you 19. You'd move your decimal 2 places, and you would have 1900%. That's not what this question asked for, but on the quiz, that's probably what I would ask for. But this says how long until there are 1 million bacteria. So what you're going to do is you just found that B was 20. So your equation, your initial amount is 5. The B value is 20, and you're going to raise it to the X power. So you would type that into Desmos, 5 times 20 to the X power. And then you want to know when it reaches 1 million. And so we'd hit our wrench here, change this to 1 million here. And we can see that it crosses right there at 4.074. So it'd be 4.074 hours. Okay, for the rabbit question, you start with 2 rabbits, and it doesn't have a growth rate here, but it does have a word you're going to use for your growth rate, and that is doubles. So since it doubles, you're going to use a 2 right there, and it's going to be raised to the X power. And we want to know how long it's going to take for Aiden to reach his goal of having 500 rabbits. So we would type in 2 times 2 to the X power, and we want to know when he would have 500. Let's go back and make this right here 500. And so we got 7.966. That's the number of cycles that his rabbit of having rabbits that he has. So it's pretty close to 8. So I went ahead and rounded it to 8. But each one of those cycles takes 60 days. So I took 8 and multiplied it by 60 to get the 480 days. So for a lot of these, like this one here, it was hours, and so your answer was just in hours. For this one, your answer is like the number of 60-day periods, so to answer it in days, you just have to multiply your answer by 60. Okay, other questions? Okay, let's see. We're not going to have time to do all of this. We're going to do a couple problems for this. Actually, I think what we'll do is, I don't want to rush the quiz, and we should really probably start about now for you guys to have adequate time. So I think we're going to push the quiz till tomorrow. We also have like a lab sort of thing that we got to do tomorrow. but I think we can get them both done. Yeah. So, you know how we did the bungee jump thing?
Yeah.
It's a little. It's not like that at all, but that sort of little experiment sort of thing. It's not bungee jumping at all, but it's like that. So, I think we'll just save that until tomorrow for the regression thing. So we'll do that tomorrow. So tomorrow, what we're going to do is we're going to do the quiz, and we're going to do the lab tomorrow. So today we're going to do this worksheet because I think we need a little more practice with this because some of us have it, but I think some of us do not. So this is what we're going to do. You may have your computers out because you will need Desmos on these, but please make sure you're working on the problems. I'll be around to help, and you can ask each other questions if you would like. But first, I'm going to fix Canvas because I've got so many out. I need them to know that the only thing they're doing today is the quiz. So, yes, that's fine. Yes.